Hello, welcome to CET 4333, Computer Organization and Design. Well, in this course, we're going to look at how a computer processor is designed. And of course, in order to understand that one, we need to look at the buses and memory systems. That will be the emphasis of the course. We have only one semester, and in that course, during this one semester, we want to teach as much as possible in understanding of computer organization and design. However, in most schools, if they have one course in one program, they usually discuss the organization in a very abstract or higher level. Well, here's the processor, here we connect processor to memory, this is how the input-output devices are, and all of those issues. However, we are not going to do basically conduct this course that way, because this is a technical program, and so what we really want to show you is how to design it step by step. Of course, you're not going to become computer architecture by taking one course in one semester, but we are going to try to show you as much as possible in detail. And that is the purpose of this course. And once we complete the chapter, the main chapters that we like to cover up is going to be 1 and 2. 1 is very simple, just we pass them. 1, 2, chapter 3, we're going to cover only very small portion of chapter 3, because chapter 3 gets into some specific computers design that we are not interested in that. We want to look overall design of a computer, not specific Sun computers or Intel computers or any of those. We are not interested in a product. We are interested in learning the concept, how to design a processor. So we're going to look at chapter 1 to a couple of sections from chapter 3, and then we want to look at chapter 4 completely. Chapter 4 is going to be our main emphasis. Chapter 5 is the advanced processor design, and it is really meant for a graduate program, for a 5,000 level course. Since we are 4,000, we're going to again to discuss very few concepts from chapter 5, and then we're going to move to chapter 6. However, chapter 6 is a review of digital technology course, or whatever the course you had them in a community college as a 1,000, 2,000 level. So, and I'm going to discuss the parts of that review that it is really we are interested right now. That would be our first 2 lectures. We're going to discuss some of those concepts that we think it's important that we know. And that's the numbering systems and data representation, how data is being represented in a computer. We're going to discuss that this point. Chapter 6 then discuss about the adders, subtractors, multipliers. We're not interested in that one, and we don't have time for that, because that's really continuation of your digital system course or digital technology. Each school calls them differently, but it's the basic digital course. So we're not interested in that one. Then we'll discuss chapter 7 towards the end of the semester. That's the memory systems. We will discuss that chapter in detail, and after that, if there is a time, we will definitely talk about some new technologies in computer design and architecture and some other issues. These are the ones. The book that you're using, it's a very good book. It is meant for a 2-semester course, and one as a 4,000, one as a 5,000. So we're going to cover only the parts that really pertains for 4,000 level. It's a very good book, and I'm going to discuss that one. Homeworks are going to come from the book, so you need to have the book. So once we finish chapter 1 and 2, you will get your first homework, and then you will get a homework from chapter 3, or I'm going to combine those chapters together. So 3 or 4 homeworks you will be given throughout the semesters, and you will have 3 exams, each one worth 25 points, and the homeworks altogether were worth another 25 points. So 3 exams makes it 75%, and then 25 points the homeworks altogether. We are going to be very strict in accepting the homework. We want homeworks via the Florida Online, and we want them on time, right? On the due date. And we're going to have a very hard time to extend that one, especially for just 1 student or 2 students. Exams, well, my lectures, except this week, it's going to be released on Monday or Tuesday, every lectures. And exams going to be online. I'm going to open them up on, I'm going to try to open them up on Saturday night, actually, give you extra time. And then you will have till Monday night or Tuesday night. If I open them up on Saturday, probably you will have time till Monday night and to complete the exam and turn them in. And final exam, or the exam number 3, also will be again open up on Saturday and close them on Monday. And once the exams are closed, you're not going to be able to extend the time or reopen it or anything. You I have to remind you, you are responsible for your network. If your network goes down, or your service provider, internet service provider, your ISP goes down, you're responsible for that one. So do not wait till 2 hours end of the window to take the exam and then the network goes down. I won't be able to do anything. If, however, up to 12 hours prior to the end time, if something goes wrong with your network, please contact me, and I'll try to help you or reopen it for you, because you won't be able to open it again. Once you open up once, you have to finish the exam. So I'll try to help you out. But once you are within the 12 hours of the exam deadline, just take the exam. You're taking your own risk. If your network goes down, you're on your own. I can't help. Now, how to contact me? You can contact me. The preferred method of contact would be email. And the reason it's email, because I like to see your email as soon as possible, and I like to respond to your email as soon as possible. And I don't have access to my voicemail all the time, right? So do not leave voicemail. If you want to talk to me, call me during my office hours, which is posted on syllabus, and contact me. To call me, I will talk to you. But don't leave a voicemail, because I check my voicemail once a day, and usually that's Monday, Tuesday, Wednesday. On Thursday, Friday, I don't even check them out, because I don't have any office hour on Thursday, Friday. I'll do committee works, other works that I have to do for the school. So, but my email, I even check them on Saturday, Sunday, and I'll respond accordingly, okay? So email is the best way to contact me. And regarding working together, I encourage you, if you get together, work together, exchange ideas, that's fine. But you are responsible to do your homework and exam alone and submit it to me alone on your own, okay? All right, I'm going to try, well, you're going to have a number of lectures. Lectures are going to be posted on Monday, Tuesday, and most probably you will have more than 1 lecture a week. And the reason for that one is I'm trying to limit the lecture time to something between 20 minutes. I've been told not to pass 20 minutes. And I'm going to limit him to 20 to 30 minutes. Then I will post as many as it's required in order to cover a subject. So expect number of lectures on Monday, Tuesday, and to make sure that you look at your lectures and you listen to them and also read the books. All right, let me go through the first topic, which has already posted. It is on Florida Online. You have access to it. And that is data and their representation. The point from this notes is first to understand how data is represented in the computer. In order to explain that one, first we need to look at the anatomy of a number. What is a number? Right? What is a number? A number, let's say 2,456. What is this number telling me? It's telling me that this tells me, this part, that this is 6 times 1. This digit is telling me that this is 5 times 10, and this is telling me that this is 4 times 100, and this is telling me that this is 2 times 1,000. Right? 2,456. But notice here that each digit in any number, in any base, this is clearly base 10 number, which is common in our daily use. This tells me that by looking at these numbers here, this tells me, oh, this is base 10, and clearly I could say this is 6 times 10 to the power of 0, because any number to the power of 0 is equal to 1. This tells me this is 5 times 10 to the power of 1. This is 4 times 10 to the power of 2. This is 2 times 10 to the power of 3. And of course, if you add them up, this comes to 6, this comes to 50, this is 400, and this is 2,000. And if you add them up, it comes to 2,456. So you notice that every number, regardless of what is the base, has a weight. And that weight, in the base 10, it is 10 to the power of 0, 10 to the 1, 2, 10 to the 2, 10 to the 3. Now, if it is base 16, it would be 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3. If it is base, let's say 60, it would be 60 to the power of 0, 60 to the power of 1. Now, the number, if it is base 10, it means we have to have 10 symbols to represent that base. If it is base 10, what are the symbols? It's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. What happens after that? It rolls over. Okay? Now, if it is base 2, what do we have? We need to have only 2 symbols, and that means we have only 0 and 1. Now you understand why binary in the computer, everything is 0 and 1, because the base of the numbers we use, it's binary. Binary meaning base 2. Now, if it is base 16, what would happen? That means we have to have 16 distinct symbols, right? And that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't roll over, right? So we have A, B, C, D, E, right? 10, 11, 12, 13, 14, and F. 15. We started from 0. So it is If you count them, 16 numbers. After this, it rolls over. This is the anatomy of the numbers, and that is something that we need to understand. Now, what is the next step? Since we know the computers picks up the binary, one of the reasons, less number of digits, so representation in the computer is much easier. How do we represent them in the computer? Well, if anything, the voltage level, that is the only way, right? The voltage level. Anything that has a voltage between 0 and 2.5, we look at them as a binary 0. Anything between 3 and 5 volts, it is 1. Well, clearly, we know sometimes the voltage may drop or gain some voltage due to some interferences or the noise. Clearly, for that reason, we have repeaters in all systems to make sure that the 0 stays same and 1 stays within the acceptable. Now, if anything gets between 2.5 and 3, we call them, it is really fuzzy, right? We don't know if it is 0 and 1. And that's totally another course that's called fuzzy logic, which is being used in appliances in today's technology. Okay, so you notice why we picked the symbol 2, because it makes the life much simpler within the computer to represent those signals. Imagine you wanted to represent them between 16 symbols. Then the voltages, making sure all voltages stay in the same level, would have been a little challenge. All right, now the thing that we need to learn before we go any further, how do we convert these numbers? How do we convert a base 10 to base 2? How do we convert a base 2 to base 8? Well, there are many ways to do it, but in today's technology, the best thing is the way I'm going to show it to you, I'm going to write you an algorithm. And that algorithm, then you can code it, you keep them in your computer, and let the computer solve that problem, right? Instead of going step by step manually. So, let me page. Conversion. That is one thing that we want to discuss. One is base n to decimal, meaning from any base, I want to convert them back to base 10, so we have better understanding. For human beings, the base 10 is very comfortable and also easy to comprehend and easy to understand. For the computer, base 2 is the major thing because it is much easier. So we need to be able to convert these numbers from one base to another base. Converting base n value is simply achieved by multiplying each digit. You see, notice here, it is achieved by multiplying each digit by its weight and adding up the results. So regardless of what number it is, let's say, whatever the number is, let's say, let's use a base 16. Base 16 number, let's say 2, F, 5. If I want to convert this one, well, I know this is base 16, right? So would be 5 times 16 to the power of 0. And this would be 15. F is 15. 15 times 16 to the power of 1. A is 10. 10 times 16 to the power of 2. 2 is 2 times 16 to the power of 3. Then add them up. All right? From any base. From any base. Historically, we have throughout the history, all these numbers have been used, and where do you think then the number 60 comes from when they say 1 hour is 60 minutes, and every minute is 60 seconds? That means at some point in time, base 60 was an important number. In European school model, in the old time, it used to be base 20. Everything was graded based on 0 to 20, not 0 to 100 that we do here. And in all different bases have been used and have served their purposes at that time, whatever the purpose was. So it is important to be able to convert. If you want to check physically, check read value of the memory on your computer for one line, you will see hexadecimal or base 16 numbers. So you should be able to convert them to decimal. That's why it's important to see these models, how we do it. Now, clearly this is not an easy way to convert a number because of how about if I have a 20-digit number? Am I going to by hand? No. The best way it is by looking at this one and writing a program. I'm going to write a program, basically an algorithm, but it is something that you could convert them easily with no effort to any programming language that you understand. And that is, I'm going to say, I define a variable, I call them value, and initialize them to 0. Then I start a loop, repeat, well, because it's the same thing being converted, right? 16 to 1, 16 to 2. Repeat. Then I say value is equal to value times n. N is the what? Is the base, plus next digit. And then I put my exit strategy, closing the loop, until no digit remain. Okay, and we'll do one example and you'll see how easy it is. Now, digits are processed. Keep that in mind. Let me put that in comment form. Digits are processed. Digits are processed left to right. Left to right. And so always start with the leftmost, leftmost digit of the value, and then work our way to the right. Okay, and let's look at one example. And that solves the problem. One example would be convert 2F3A, which is base 16, to decimal. Right? So we initialize first, initialization, let me call them. Value is equal to 0. Remember that the code that I wrote, all right? It is no language, no computer programming language special, right? the way I wrote it, you can do it in any language that you are familiar with. Value is equal 0. Then, first pass, we start from the leftmost. We say value is equal to value times 16. Well, we said times n, right? We said times n, times 16, and then plus next digit, which would be 2. Right? First pass, I don't have any value. Value is initialized to 0. Next digit is 2. We start from the leftmost. So what's this going to be? 0 times 16, 0. So this is equal to 2. Now value is equal to 2. The second pass, we say value is equal to value, which is 2, times 16 plus next digit, which is f, that's 15. 2 times 16, it is 32. 32 plus 15, it is 47. Third pass is value is equal to value, which is 47. 47 times 16 plus next digit, which is 3. And this would be 755. Fourth pass, I will do the passes until I go through every one of these digits, right? So value is equal to 755 times 16 multiplied by, plus a, which is 10. And this comes to 12,090. So the answer is value, and that's equal to 12,090 in base 10. As you see, it is very easy using that algorithm and solve this problem. Now, I'd like to go through the proof that why my algorithm is working. And why I got that algorithm based on these numbers. And so you can see how I came up with this algorithm and how the algorithm is correct and is giving me the right answer. All right, what I'm going to do, I'm going to stop at this point because I'm already over 28 minutes, and then post another 15-20 minutes of lecture after this one in this week. So this week you will have, even though this week you're supposed to have just one lecture, I'm going to have, but I wasn't able to finish what I want to finish. So I want to show you the proof, and so I will record another short lecture this week, and you will see part 1 and 2. All right, I'll stop at this point.